Hi students, we're going to talk about how to graph an exponential function, something like f of x equals e raised to the x power. So our base is e. We're going to be raising that e value. E is about 2.7. And notice I made a table of solutions. I did round them, the smallest ones to the 100th place, and then the larger values just to the 10th place. Now the reason why is because anything further than that in terms of precision, I can't graph very accurately on this type of graph that I've drawn. So that's plenty of precision right there. That'll allow me to ballpark where the ordered pairs will go to show our function. Let's choose a different color now to graph these. Let me start actually at the bottom up, because then it'll be easier for me to graph the remaining very small values of f of x. Now, if x is 3, f of 3, meaning e to the third power, is equal to 20.1, about approximately. My graph only went up to 10, so I'm not going to graph this point. The next one, though, e squared, e to the second power, is about 7.4, and that's for x equals 2. So x is 2 here. F of x will be about 7.4, about right there. F of 1, e to the first, or e, our Euler's number, is 2.7. So about right there. F of 0, e to the 0, like any base raised to the 0 power, is going to be equal to 1. And there it is right there. Now, f of negative 1. So this is e to the negative first, or 1 over e to the first, or just 1 over e. It's equal to 0.37. So as you probably are seeing now, I can't graph these really accurately because they're so small. My scale is just every 1. It's not every 10th or every 0.5, and it's not necessary for this. This is fine for us to see the behavior and see the graph of this function. So what's happening as x is getting smaller? Well, f of x is also getting smaller. It's getting closer and closer and closer to the x-axis. If I sketch this graph, that's the intent. That the x-axis, y equals 0, is actually a horizontal asymptote for this function. It bounds it, meaning that there will never be any part of this graph in quadrant 3, or as you can see in quadrant 4. All of it will remain in quadrants 1 and 2, depending on your value of x. Hope this helps. Bye, students.